This is section 8.6, the Pythagorean theorem. Okay, so the first thing that we're going to do is we're going to do activity 1 on page 480, and we're going to do it on graph paper instead of using a ruler and a compass like they say. I think it's easier just to do it on graph paper. So we're going to do that here. So it says use a protractor or compass to draw the right triangle HFG with, and then it gives 2 centimeters and 3 centimeters. We're just going to use the little squares on our graph paper instead of measuring. And basically we're supposed to copy that picture off to the right there with that square and then the square inside of the square. So what you want to do is you just want to make a square kind of like that. So that square, if you've got a 2 by 3 triangle like they've got, that would make all your side lengths 5. So basically I'm going to start with a 5 by 5 square. So that's one of my sides. 1, 2, 3, 4, 5. Do another side here of 5. Keep going. Okay, so got our 5 by 5 square, and then you're just gonna try to replicate what they've got there for their 2s and their 3s. So like on their picture, they've got that this is the 2 and this is the 3. So just from 2 to 3, I'm just gonna shoot a straight line there. That, and then just kind of work your way around the shape doing the same thing. So like the next one here, this is your 2 and this is your 3, so 3 there, shoot that line, and then you've got your 2 here, so the bottom one's your 3 is right there. And then your last one should meet back up with each other because that's your 2, that's your 3. Shoot your line there. And that should look like that picture there. Okay, and then what they ask us, it says, okay, trace it, and then it says what justifies the conclusion that F, B, C, D is a square. So you should probably put the letters in here. So we've got F, B, C, and D, and then we've also got G, N, L, and H. Okay, lots of labels there. Alright, so what justifies that it's a square? Well, from our picture there, if these are all right triangles, that means all of these little corners are 90 degrees. So if you've got 4 corners that are 90 degrees, that would be part of what we need to say it's a square. And then we also know that all of these side lengths are 5 because it's 2 and 3, 3 and 2, 3 and 2, 3 and 2. So all of those side lengths there would add up to be 5. So like from there to there is 5, and also there to there is 5. So if all 4 of your sides are the same length and you've got 90 degrees in the corner, that would be that making that a square. And then for the next part of that, for 3b, it says find the area of that. So for step 3b, A you could write down if you want to, but B says find the area of that squares. So to find area of a square, we take base times height, or you could do, since all your sides are the same, it's basically one of your lengths squared, so either 5 squared or 5 times 5. So our area of that whole thing there, so this is area of F, what letters did they go in? They went F, B, C, D. 5 squared would be 25. And we'll just go unit squared. I know they asked us to do it in centimeters, but since we did it on the graph paper here, we'll just go unit squared. Okay, so that is step 3. Step 4, what we want to do is it says measure the sides and angles of GHLN and figure out what type of shape that is. Okay, so Now they want us to look at this inside shape here and figure out what kind of shape that is. So if I look at my corners, they should end up looking like they're all 90 degrees. So if I go around and check all those corners with my protractor, should end up looking like 90s in all of those. So I'm going to mark in 90s for all those angles. And then also, we can measure our side lengths here. So if we measure it, I guess I'll switch to centimeters, that might be easier. Mine comes out to be about 23-ish millimeters. And if I look there, about the same thing. About the same there. And about the same there. So since those all have about the same distance, I'm just going to mark in here that all those sides are the same. You could put, whatever it measures out to be in millimeters or whatever you measured with, but you don't necessarily need that. And then, so then it asks, well, what kind of shape is that? Well, similar to our outer one there, we've got 4 90s in the corners, right? And all 4 of those sides are the same. So for 4B, when they ask what type of figure it is, well, it's got to be a square, right? Okay, so then from there it says measure, no, we're already past that step. Now it says use the following relationship to find area of GHLN. So what it says there with all that stuff they're subtracting is they want us to take the area of, highlight these here, they want us to take the area of these green triangles, so the ones we had before, and they want us to subtract those away from our big square here. And if we do that, what we should be left is that inside part. So what I'm going to do is I'm going to take the area of that bigger square, that pink one, which we know our dimensions there are 5 by 5, so that area came out to be 25. And from that, I'm going to subtract away the area of all those green ones. So I probably want to figure out the area of one of those green ones, and then I know their areas are all the same, so then I could take whatever I get for that times 4. So if I find the area of one of my little triangles, so that is 3 by 2, so I would want to take half of my height, which would be either the 3 or the 2, so I'm going to go 3, times my base, which would be the other number 2, so that would be 3 times 2 would be 6, times a half. The area of each one of those little triangles is 3. And then if I've got 4 little triangles there, to figure out the area of all 4 of those together, I could take 3 times 4, which would be 12, so the areas of all my greens together would be 12. So then if I need to find the area of that inside part, I'm going to subtract away my big square, the pink, minus my greens there, and I should get 13 square units or units squared for my area of that inside part. Put that in there if you want to. And then from there, step 6 says it wants us to use the area of that to find the length of one of the sides. Okay, so now our goal is to find one of the lengths here, so like maybe say like G to N. So what we need to do is we almost need to work our area of a square formula backwards. So our area of a square we know is whatever one of our sides is squared. So like in this case, we don't know what one of those sides is, so I'm just going to make it like S. But I do know that my area is 13. So I'm going to plug 13 in for the area, and S is just going to be my side length I'm trying to figure out here. So if I need to solve for this for S, to get rid of squaring something, what you do is you do the square root. So when I do the square root and squared cancel each other, so it's just S for my side length there. And then I'm just going to leave it as square root of 13. You could take and figure it out as a decimal, but it's not a very nice decimal. So I'm just going to leave it as my side length in here is going to be square root of 13. Okay? Now that might seem kind of confusing, but what that kind of leads us to is Pythagorean theorem, which is the next thing we're going to talk about. So jot down that formula there on page 481, and it might not be a bad idea to draw that picture that's off to the right there, with the different squares and then the triangle there. That's a very common picture that gets used quite often. So that might not be a bad thing to have in your notes. But it says for Pythagorean theorem, in any right triangle with legs the length of A and B and hypotenuse the length of C, we can use the formula A squared plus B squared is equal to C squared. And you may have used that formula in other classes. This formula only works for right triangles. It won't work for, just isosceles or scalene or anything like that. It only works for right triangles, okay? What else? So there's also the alternate form of, or alternate statement of that Pythagorean theorem. Might not be a bad idea to have that one written down too. So it says in any right triangle, the sum of the areas of the squares on its legs equals the area of the squares on its hypotenuse. And that's kind of what they're getting at with that picture there, is they've got those squares and then they take the square root of each of those sides and they get the lengths of the triangle. So basically you got your triangle here, you got your 90 there, they've got a square there, a square there, and a square there, and they're saying, okay, well, if the area of this one is C squared, the area of this one is, what do they have there, A squared, and the area of this one is B squared, then the lengths of your sides would be the square root of that, because these are squares here, so C, A, and B. Okay, so that's kind of where that formula comes from. You don't really need to know a whole lot about that. You mostly just need to know the formula, but sometimes it's nice to know where it comes from. Okay, so let's try an example here. So we've got a soccer player kicks the ball east for a distance between 50 and 65 yards. And the player also is going to kick another ball south for a distance between 40 and 50 yards. And we're supposed to figure out the range for the distances between the two soccer balls. Okay, so thinking of a compass here, we've got north, east, south, and west. So with compasses, anytime they talk about directions, it's always 90 degrees in between all of those, like on a map. So that's going to be nice here, because then what we can do, since it's going to be 90 degrees, we can end up using our Pythagorean theorem. So what I'm going to do here is I'm going to kind of draw a picture. So we got the soccer player, it's right there, and it says they kick the ball 50 to 65 yards east. So if I'm going east here, say that's our 50, that's our 65, and that ball is somewhere in between there. So, it could be closer to 50, could be closer to 65, we have no idea. Now, we're going to kick another ball directly south. So based on our compass rows here, if this is east, south is going to be 90 degrees apart from that. I'm going to shoot my line down here. 90 there, and this one is going to be between 40 and 50 for our range. So, and then the ball is in between there somewhere. So what we're going to do here is we're going to think of this kind of like triangles. So like if we shot a line here from the 40 to the 50 and the 50 to the 65, it's a very good line. What this is going to do is it's going to give us a range of these possible dimensions here. So like say our ball is right there and maybe like right there. Well, that's one option. Maybe our ball is right here and then right there. That would be another option. Okay, so we're coming up with a range. It's not going to be an exact answer. It's just going to be like from this number to this number is where it could be. Okay, so that ball could be any of these in-between distances here. Okay, so let's use Pythagorean theorem to figure out our low distances. So say the ball was right at 40 and right at 50. This line here would be our closest possible one for our range. And then this one here, 50 to 65, would be our farthest possible for the range. Okay. So if I want to figure this out here, if I'm thinking this is my right triangle, maybe I make this side my A, this side my B. Well, from here to here is 50. From there to there is 40. So say I went A squared plus B squared is equal to C squared. My C is what I'm trying to find. So my A would be 40 squared plus my B would be 50 squared is equal to C squared. 40 squared would be 1600. 50 squared is 2500 is equal to C squared. Well, if I add those two values together, I get 4100 is equal to C squared. And then to solve for C, I would want to take the square root of both sides. So my C is equal to square root of 4100, or if you wanted to, you could do your approximation for that. It just depends on what they are asking. So if I do my approximation on that, I would just do square root of 4100, which would be about, we'll go 64.03. Somewhere in that range, and we are doing yards here. Okay, so that is on our low end. So the lowest possible range we could, or the lowest possible distance we could have would be 64.03, about that. So that would be this side here. Now what we want to do is we want to find our longest possible distance, which would be between the 50 and the 65. So I'm going to do that same thing with the 50 and the 65. So this time my A would be from here to the 50, so my A is going to be 50, and my B would be from here to the 65, so my B is going to be 65. So I would go 50 squared plus 65 squared is equal to C squared. Again, my C is the hypotenuse that I'm trying to find from 50 to 65. So 50 squared is 2500. 65 squared is 4225. That's equal to our C squared. So we're going to want to add those together, which would be 6725. It's equal to our C squared. Then to find the C, square root. So our C is either equal to square root of 6,725, or we could figure out our approximation there on our calculator. Square root of 6,725, which would be approximately 82 point, so you got 0.00, but if I look to the next one, it's 6, which would round that up to 1. And we are yards for both of those. So our possible range is either using our square roots from square root of 4,100 yards to square root of 6,725 yards, or since those don't really make sense for numbers of yards, we might want to do it as our approximation. So approximately 64.03 yards to 82.01 yards. Okay? Alright, next thing here is Pythagorean converse theorem. So we remember converse is basically just taking and flopping, you know, like an if-then statement around. So like if something, then something. So what we want to do is we want to take the back part, put that in the front, and the front part in the back, and that's the converse. Okay, so just switching the order of those two things. So what that theorem, or what that converse says, is it says, suppose a triangle has side lengths of A, B, and C. If this A squared plus B squared is equal to C squared, then it's a right triangle. So in our original Pythagorean theorem, they told us that it was a right triangle from the start, and then we used that formula to find the side lengths. Now what they're going to do is they're going to give us the side lengths, so like you'll kind of see down here, and we have to figure out if that's a right triangle. Okay, so it's kind of the opposite of what we were doing before. What they call these, if it does come out to be a right triangle, is called Pythagorean triples. So it's a set of 3 whole numbers that can be the lengths of the sides of a right triangle. One of the most common Pythagorean triples is a 3-4-5 triangle. So a 3-4-5 triangle would look something like this. You got 3, 90, 4, and then 5 there. And this is a Pythagorean triple because if I take 3 and square it, I get 9. 4 and square it, I get 16. Add those together, I get 25. And if I took the square root of 25, that gives me my 5. So that formula there comes out to this here. Both sides are equal, so that comes out to be a Pythagorean triple. Okay. So let's do some actual examples of this here. So what we're supposed to do is we are supposed to kind of think of this as the converse, and we are supposed to figure out if these are going to be right triangles or not. So it says, and if not, decide whether it's going to be acute or obtuse. Okay, so what we want to do here is we want to take and use these numbers, assign them A, B, or C, and then plug them into that Pythagorean theorem. If both sides come out to be nice, it's a right triangle. If they don't, then it is not. So here, we'll make that our A, our B, and our C always has to be the biggest one, so the C has to be the 28 here. And then what I do is I just do A squared, so 7 squared, plus my B is 22 squared. It's equal to my C squared, which is 28 squared. So then if I solve this out here, 7 squared is 49, 22 squared is 484, and 28 squared is 784. And then if I add together my 49 and my 484, that comes out to be 533. And then my other side is 784. And I know that those are not equal to each other. So this would not be a right triangle. Then what we want to do is we want to figure out if this is acute or obtuse. So what you do is you look at your different numbers here. If this number here that we solved out for on the A and the B side is smaller than the number over here for the C, which it is, so 533 is less than 784, then that would be an obtuse triangle. So if your A squared plus your, and maybe you want to write this, if your A squared plus your B squared is less than your C squared, it's going to be an obtuse triangle. If it's the other way around, your A squared plus your B squared is greater than your C squared, then it's going to be an acute triangle. Okay, if they come out right on the dot and equal each other, so like 533 equaled 533 or something like that, then it's a right triangle. If not, then it's one of those. Okay, and then the next one here, we'll try this one as well. So we got 15, 18, and 23. So I'm going to go A, B, my C's got to be 23. So if I go 15 squared plus 18 squared is equal to 23 squared. Well, 15 squared is 225. 18 squared is 324. And 23 squared is 529. Then if I add these two values together, I should get 549, which would not be equal to 529. It's a lot closer than the last one, but still not equal to each other. So in this one, my A squared plus my B squared would be bigger than, because 549 is bigger than 529. So if it's bigger there, then this would be no, and this would be acute. Okay, so if when you add your A squared and your B squared and they're bigger than your C squared, acute. If they're smaller, then obtuse. And if they're right on the money, and maybe you want to write that too, if they're right on the money, A squared plus B squared is equal to C squared, then it's going to be a right triangle. Okay? Alright, so that is it for notes. So your book page assignment is 484, 1 to 14 all, and 16 to 22 even.